In this video, we're going to talk about radical expressions. Now, here's the thing about radical expressions. If you've seen when we've worked our way through this exponential chapter, when we're trying to solve exponential functions, we often have to use radicals to help us solve, especially if we're trying to solve for what the base is. And so in this video, we're going to look at applying some of these radicals and simplifying them. Now, the radical that we're going to focus on in this video is the squared root. It's the most common that we encounter. Now, we can have any powered roots. We've seen in a previous example that you can have cubed roots or fourth roots or really any power of the root. Now, the power of the root is indicated by the number that's in the corner of the radical symbol here. Now, if there is no number there, it's an implied 2. And I have that written here. So the squared root is the same thing as the second root of x. Now, simplifying is a lot easier if you know your perfect squares. And so I have a perfect square table here from 1 to 25 and for our reference. Now, the process of simplifying square roots, what we're trying to do is we're trying to break down the number that's inside of the radical into its factors. And I want to try to find a perfect square as one of the numbers that makes up the product of the two factors that's inside the radical. So, for instance, 8 is the same thing as 4 times 2. 4 is a perfect square. So what I'm going to do is I can rewrite the square root of 8 as equaling the product of the square root of 4 times the square root of 2. Well, we can take the square root of 4, the squared root of 4, because since 4 is 2 squared, is 2, and I can't simplify the square root of 2 at all, and so I leave it as the square root of 2. There's my answer. So the square root of 8 is simplified to being 2 times the square root of 2. Now we're going to do the same thing again here. The square root of 12. I want to break it up and I want to simplify this radical. So 12 is the same thing as 4 times 3. Now, since that's inside the radical, I'm going to rewrite the square root of 12 as the square root of 4 times the square root of 3. Well, we can take the square root of 4. The square root of 4 is 2. And I leave the square root of 3 just like it is because I can't simplify that. And there's our simplified radical. Okay, now we're going to look at another number. So the square root of 24. I want to simplify that radical. All right, well, 24 is the product of 6 times 4. Now, 4 is a perfect square. We can take the square root of 4, but 6 is not. Now, 6 is 3 times 2, and I can't break that down any farther. So what that means is I can't do anything. I can't simplify 6 as being a simplified square root. So all we're going to do is we're going to rewrite the square root of 24 as the square root of 4 times the square root of 6. We're going to take the square root of 4, which is 2. We've seen that in a couple of examples now. So it's be 2 times the square root of 6. And that's our simplified form. Now let's simplify the square root of 45. So we'll break 45 up into the product of its factors. 45 is 9 times 5, and we're trying to find a factor that's a perfect square. 9 is a perfect square because 3 squared makes 9. And so I'm going to rewrite the square root of 45 as the square root of 9 times the square root of 5. We can take the square root of 9. Square root of 9 is 3. And so our simplified form of that radical would be 3 times the square root of 5. Now let's look at 72. Okay, well, 72 is 9 times 8. Now, 9 is a perfect square. Now, here's the thing. Once you break this up, you want to continue to look to see if maybe I can't break these factors up a little bit more. 8 is the same thing as 4 times 2. So 9 times 4 times 2 will make 72. Well, 4 is also a perfect square. So I can write the square root of 72 as the square root of 9 times the square root of 4 times the square root of 2. Well, we can take the square root of 9, that's 3. We can take the square root of 4, which is 2, so we have 3 times 2 times the square root of 2. Well, 3 times 2 makes 6. And so our simplified form of this radical will be 6 times the square root of 2. All right, now we want to simplify the square root of 112. Well, we're going to go look at 112. We're going to figure out what times what makes 112. And 112 is the product of 7 times 16. And so I look at that. 7's a prime number, but 16's a perfect square. So I could rewrite that square root of 112 as the square root of 16 times the square root of 7. The square root of 16 is 4. So I could simplify this radical to being 4 times the square root of 7. Okay, now we want to simplify radical expressions so I have more than one radical in my problem. Well, in order to simplify, we're basically trying to combine like terms. So anything that has like square roots, we're going to combine them just as we would if they were x's. Now, however, in order to do that, I have to have the same square roots being applied. So if I look at this first problem, I got the square root of 54, and I got the square root of 6. I can't add them together because they're not like terms. So what I want to do is I want to see if I can't simplify the roots a little bit so that way they look the same. 54 is 9 times 6. So I could rewrite the square root of 54 as being the square root of 9 times the square root of 6. And then I got plus my square root of 6 still. Well, the square root of 9 is 3. So we have 8 times 3 times the square root of 6 plus the square root of 6. 8 times 3 is 24. So if I have 24 root of 6 plus another square root of 6, that means I have 25 square roots of 6's. All right, this next one here. So negative square root of 3 plus 5 times the square root of 108. And I want to simplify that. Well, what I need to do in order to simplify it, I need to make both of my radicals be of the same number. So I need to end up with the square root of 3. So I'm going to cheat here, and I'm going to try to figure out what times 3 makes 108. And 108 divided by 3 is 36. So we're going to simplify that square root of 108. And what we're going to have is that square root of 108, same thing as the square root of 36 times the square root of 3. Well, the square root of 36 is 6. So I have plus 5 times 6 times the square root of 3. 5 times 6 is 30. Now we put those together. Well, negative 1 square root of 3 plus 30 square root of 3 gives me 29 square root of 3. Okay, now let's look at how we would multiply square roots together. Well, when we simplify square roots, in order to simplify them, we have to actually look at the process of multiplying them. When you multiply square roots, what you do is, if they are the same powered root, you multiply their insides together and then look at simplifying. So the square root of 3 times square root of 30 is the same thing as the square root of 3 times 30, which is going to be the square root of 90. Now, I don't celebrate and think I'm finished because I want to simplify that radical. Now that they're put together, well, 90 is the same thing as 9 times 10. So I'm going to simplify the square root of 90 to being the square root of 9 times the square root of 10. The square root of 9 is 3, so I have 3 times the square root of 10. Okay, now we're looking at this next. I want to find the product of 4 roots of 6 and 7 times the square root of 18. Well, that just means multiply them together. So 4 times the square root of 6 times 7 times the square root of 18. Well, I can multiply the numbers in front of the radicals together. That gives me 28. And now I'm going to look and figure out what goes inside the square root. Well, inside the square root is going to be the product of the numbers inside. So the product is 6 times 18. And that's going to give us 28 times the square root of 108. Now we want to simplify that square root of 108. 108 is the same thing as 36 times 3. So we're going to break up this problem. I'm going to come over here. So we'd have 28 times the square root of 36 times the square root of 3. We can take the square root of 36. That makes 6. So we have 28 times 6 times the square root of 3. And so our final answer here for that product is going to be 168 times the square root of 3. All right, now we're going to look at dividing radicals. Well, similar to when we multiply square roots or radicals together, if I am dividing radicals together, there's actually two ways of doing this, but the way that we're going to do here is if I'm dividing two radicals, I can combine them into one radical with the division of their insides. So 180 divided by 9. And so 180 divided by 9 would make 20, so I'm looking at the square root of 20. Now I have a problem that's just like what we started this video on. I want to simplify the square root of 20. So 20 is the product of 4 times 5. 4 is my perfect square. So I'm going to write square root of 20 as the square root of 4 times the square root of 5. The square root of 4 is 2. So my final answer here is 2 times the square root of 5. Now in this problem I'm looking at, I have the square root of 48 divided by 4. I cannot divide their insides because I have the square root of the top, but 4 is not inside of the square root. So what I'm going to do here is I'm actually going to write this problem. Remember, division by 4 is the same thing as having 1/4 times that square root. So I'm going to write it this way. Now what I do is I simplify the square root of 48. 48 is the product of 16 times 3. 16 is my perfect square. And so what I have is I have 1/4 times the square root of 16 times the square root of 3. And we just simplify from there. We'd have 1/4. Square root of 16 is 4. And then I have times the square root of 3. Well, 1/4 times 4 makes 1. And so all we're left with here as our answer is the square root of 3.